Okay, so we just talked about rigid transformations, which are ones that have H and K terms. Now we're going to talk about non-rigid transformations, and what that does is it has an A term that makes the graph skinnier or fatter. You also have to pay attention to the sign of the A term, because a negative indicates a reflection. All right, so let's work with a basic x squared graph. And the whole point behind the 1, 1 points is to add a little accuracy to your graph, but also I don't want to be super picky when it comes to your graphs, but I am looking for certain things. If it's a skinny graph, I want it to be inside of the 1, 1 points. And if it's a fat graph, I want it to be outside of those points. So anytime you have a non-rigid transformation, I want you to make a conscious effort to establish whether it's inside or outside of that 1, 1 point. Yep, and here's a whole bunch of 1, 1 points. Yeah, yes, because we've never seen this before. All right, getting back to it. If A, and I want you to ignore the sign on the number. Okay, the sign just tells us whether or not it is a reflection or not. But if A is less than 1, that means the graph is fat, indicating that it's going to go outside of the 1, 1s. If A is greater than 1, that tells you that the graph is skinny and that it will lie inside of the 1, 1s. All right, so if we have y equals 3x squared, 3 is greater than 1, so that indicates to us that it's going to be skinny. Okay, specifically, instead of over 1 up 1, it's over 1 up 3. It's rising 3 times faster than it normally does. And you'll notice that the green graph there is inside of the 1, 1s. Okay, and there you can see that instead of 1, 1, it's over 1 up 3. All right, how about if we have y equals 1/2 x squared? 1/2 is less than 1, so that indicates that it's going to be a fat graph. It's going to be outside the 1, 1 point, specifically over 1 up 1/2. Okay, I'd like to go over just another example. I gave you a couple of examples with the x squared. I should probably show you something that is different than an x squared. So let's take a look at how about y equals 2 absolute value of x. All right, normally our absolute value of x is going to look like this. But the 2 makes it steeper. Specifically, it's going up twice as fast. So instead of going over 1 up 1, we go over 1 up 2. So our graph is going to look like this. Okay, how about, let's try, square root. Y equals 1/3 square root of x. All right, normally our square root is going to go through that point and that point. But since it's 1/3, instead of going over 1 up 1, it's over 1 up 1/3. All right, for that second point right there, instead of being up 2, it's going to be up 2/3. It's going to be right there. So it's going to be very, very flat. All right, I think that's a good good indication of how to handle those A terms with other types of functions. So I think that's a good spot to stop.